Hi, my name is Gene, and I'm a new mentor for high school robotics team FRC 714 from Newark, New Jersey. We made this video series about how ridiculously easy it is to program FRC competition robots in Python, a language of many modern apps and AI products. I think it's just easier to program these robots in Python than to do it in Java. In the previous video, we have set up the smallest and safest FRC robot. It's called XRP. And it's also very cheap. And we ran some super simple code on it, so we could drive it with a joystick and use its distance sensor to avoid obstacles. That was fun, and please watch that video if you haven't, but that's not enough to win competitions. Now, if you look at the code of the teams that actually did win FRC World Finals in the last few years, everyone was doing one thing. They were splitting big, complex pieces of logic into many small blocks of code that are called commands. This is called command-based robot code, and every winning team is doing that. So today we will learn how to write small commands using our small robot. For example, arm up and arm down, or a command to drive 10 inches forward and make a right turn. Let's get to it. In the previous video, we have installed PyCharm and Git, so we can download some Python code from GitHub and play with this and make changes to it. So this is the link to the code that we're going to be using for this video. It's just an example that I have put on GitHub. And the link is in the description. What we need to do is we need to open our PyCharm. I'm just gonna go open my PyCharm in here. If some project is already open in it, which it is in here, I'm just going to go to the file menu and say close project. And now we can use this link, this GitHub link, to get the code from GitHub by clicking the Get from VCS button. In the URL, I'm gonna paste the URL of the code on GitHub and hit clone. Clone means download when you're dealing with Git. Downloading, cloning, and here we are. Okay, so if I click the upper left button called Project in PyCharm, I'm supposed to see these files in here. If you don't see them, then okay, sometimes it happens. PyCharm is not perfect. What you do is you go here to File menu and you say Close Project. And then you open that project again. And the files are supposed to appear if you have downloaded them from GitHub. Now what we need to do is, of course, we need to click on the lower right corner. That's very important. And we need to create a new virtual environment with some of the things that this code depends on. To do this, we click on this lower right corner and we say add new interpreter. Add local interpreter, and we pick the version of Python that we have downloaded. In my case, it's Python 3.9. If you have Python 3.11, that will just work fine as well. And hit OK. The virtual environment is getting created. And because we're using virtual environment, what we need to do is we need to click on this project button and then click on requirements file. And inside of that virtual environment, we need to install all of the things that we need to install for the robot code to work. They are called requirements. They are other Python packages that have the code that we need for this robot to work. One is called robot.py and the others are here. Normally you can just right click them or hover over them and you will be offered an option to install all missing packages, just like this. I'm gonna say yes, 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 install them all. Here on the bottom, you can see some sort of a progress bar with them. If you're on Chromebook, it will take forever. If you're on Windows or Mac, it will be pretty quick. The dependencies, as we call them, are installed. And let's see what kind of code do we have for this robot. It's a command-based robot, so there is a folder here called commands. Each command is some sort of an action that can be done with one or more subsystems of a robot. For example, arcade drive is a command for the robot to drive, normally by using joystick input or something else. Now, drive distance is an interesting command. It's a command in which you must give it the speed and how many inches to drive with that speed, and the robot will perform the action. If you want to make your own command, it's actually pretty simple. You need to create a command like this in which you have to write 4 functions. Initialize is the function in which you say, when the command starts, robot must do that. For example, in this case, drive train, go with speed 0, which means second function to put in your command is execute. What should the command do? What should the robot be doing it while the command is in progress? Third function is end. What should the robot do when the command is finished? And finally, there is another function that you need to write, is finished. Here in this function, you tell the robot when do you consider this command finished. If this all went over your head, do not worry. Most of the time you're not going to be making your own commands, but you're going to be using some commands that are already made. With that, let's look at how we're going to do this. Another folder here is called subsystems. This represents which subsystems the robot has. Now, because our robot is very small, it only has 2 subsystems. It has a drivetrain, and inside of a drivetrain there is left motor and right motor. And it also has an arm subsystem. I click on the arm, and inside of the arm there is only one servo motor, which you can command to be at different angles. Angle 0 means arm down, angle 90 degrees is arm up, 45 is maybe somewhere in between. The function is called set angle. Finally, this is what you really will be doing when you're working with a command-based robot. If you go to this robot container class, you need to define which of the subsystems your robot has inside of the init method. Here our robot has one drivetrain and one arm. Now imagine that our robot also had a water gun. We would be saying self.watergun in here equals water gun. Presumably water gun was code for the water gun was written somewhere else. But our robot does not have a water gun, so we're not going to have it on our robot. Finally, the most fun part is to say which button on the joystick will do what kind of command. This is done inside of a configure button bindings function, traditionally. You can do it in other places too, but the tradition is to put this into configure button bindings function. Here is a command, go forward 10 inches. It is defined as drive distance with the speed equals 0.9, inches equals 10, using the only drivetrain that we have, self.drivetrain. And then we want to bind it to the Y button of our joystick. So our joystick is called J0, self.j0 is the command Xbox controller. Yes, we all love Xbox in our team, so we're using the Xbox style layout for keys on the joystick. In order to bind the command that we created to the Y button of our J0 joystick, we say self.j0.y button dot on true. On true means when pressed for a button. And then we need to say which command to put when the button is pressed. Well, this one, forward 10 inches. This is what we want to do when that button is pressed. Let's see if it works, shall we? I take out my robot and I'm going to power it on. So the light is red. Next, I'm gonna take my green joystick and I'm going to plug it into my computer. Just like this. And finally, I'm going to connect to the robot Wi-Fi. If the robot is on, the Wi-Fi should be up, as you saw in the previous video. Here, connect. Connect to the XRP Wi-Fi, the Wi-Fi network of the robot. We're now connecting to it. Soon. Finally, I can start the robot code by hitting the run button. The Wi-Fi is connected and the simulation interface came up. Now, let's make sure that our joystick, which shows up as Xbox controller here, is indeed in port number 0 by dragging it from here, menu of joysticks, to virtual joystick ports. Second, let's switch our robot from disconnected state to the teleoperated state. And last, let's see if the Y button actually now works with the command for the robot to go forward 10 inches. I'm pushing the Y button and I'm looking. Are the wheels spinning? Yes, the wheels have spun by 10 inches. It works. Let's put other commands in. I'm hitting the stop button here in PyCharm and I'm going back to code. Let's see. Here in the code, I see an exercise. Exercise 1. Here is a command to drive back 10 inches. It's pretty clear. Speed is negative, so the robot will be driving back. And number of inches is 10. And we're using the same drivetrain. The exercise is, can you hook this command or bind this command to the button A on the joystick? I think I know how to do this. So joystick is self.j0 because this is where we put it. See, we said self.j0 is the command Xbox controller, the joystick. So we say self.j0, which button? A, the A button, right? On true, which means when it is pressed, what we want is we want to run the command to go back 10 inches. Okay, which other exercises do we have in here? Now we go to instant commands. Instant commands are the commands that are one-shot commands. For example, arm up. Arm up is a one-shot command. And what's happening is when button X is pressed, to this event, we're binding the arm up command. Now, here's a command for arm down. You can actually bind it to the same button, but when the button is unpressed. All you have to do is you have to say that X button on false, which is when unpressed. And you provide the command that you want to run when the arm is, when the button is unpressed, which is arm down. Inside of the arm down command, what we do is we say set angle 0. And inside of the arm up command, we say set angle 90. Arm go 90 degrees up. Now, you might have noticed this word lambda. What the hell does lambda mean? Lambda means do it later. So when you're creating a command and binding to the button, this is not the right time to put the arm up or down. You gotta do it later, when the button is pressed. So in Python, the keyword for this is lambda, not later, even though maybe we should have said later. So lambda means later, for all intents and purposes here. Exercise number 3. Can you make an arm half up command and bind it to the B button pressed? Okay, I'm just gonna copy this command arm and I'm going to create a command here arm half up. I'm gonna call it arm half up. And instead of 90-degree angle, I'm going to give it a 45-degree angle. And we want it on button B. So I say self dot joystick J0, and we want the B button. And this B button also has on true event. On true means when pressed for a button. Button when pressed, and when pressed, I want this command to run, arm half up. We can test this. So far, what do we have? We have added a command for the robot to go back 10 inches if button A is pressed. And we have also added a command for the arm to go half up when B is pressed. Okay, turning.
Во, Женя.
Oh, look, my son made a robot. My son made a robot out of blocks. I think it's a pretty cool robot. And what I have done now is I have pushed the run button for this robot that we're building with you guys. And the simulation interface came up. Now let's see. So we had the B button for the robot to go back. So again, I drag my joystick into port number 0 here, and I switch the robot state to teleoperated. Let's test the B button. Will the robot go back? B. Oh, I'm sorry, that was the arm half up. Arm indeed went half up. Great, 45-degree angle. And the robot going back was bound to A button. I'm gonna hit the A button. Will the wheels be turning back? Yes, the wheels are spinning back by 10 inches. So far so good. Which other exercises do we have? Stop.
Daddy, can I push X?
Of course. Which button do you want to push, Daniel? X? V. I don't think we have anything on that button yet. Let's keep doing those exercises yet. Yeah, so this button doesn't work yet. Now let's see, we have an interesting command here. Turn right by 45 degrees. We say rotate angle, we say 45 degrees, and we give it a positive speed, which means a right turn. But we can make another command out of it, which is turn right by 45 degrees, but do it for at most 5 seconds. What we do is we say right 45 degrees, the command that we just created, and then we say dot with timeout. And then we just gotta give it a timeout, for example 5 seconds. So if the command is not done, in 5 seconds it's gonna stop anyway. And this command gets hooked to the right bumper. Now here's an exercise. Can we make a command to turn the robot left by 45 degrees and with a 3-second timeout? I think I can do this. So this is the right 45-degree command. I'm gonna copy it and I'm gonna set speed negative, minus. And now we're gonna give it a 3-second timeout, like this. And we're gonna call it left, not right. Left 45 degrees. Left 45 degrees with a 5-second, no, with a 3-second timeout. Which means if it's not done turning in 3 seconds, the command is stopping anyway. And we're gonna put it on the left bumper of the joystick. So we say self.j0.left bumper on true, and we put this command left 45 degrees with a 3-second timeout onto it. Yeah, I think this was our exercise 4B. We're binding this command to the left bumper button, left bumper of the joystick. Finally, we can connect multiple commands together. Look, here's a command to drive forward by 8 inches. This is a command to turn right by 90 degrees. Then a command to drive forward by 8 inches again, and a command to turn right by 90 degrees. Here they're all connected. Forward 8 inches and then. So in order to connect the commands together, you can say dot and then. And then we say after this right 90 degrees. And then we say dot and then. Forward 8 inches, this command, number 3. And again we say and then, and we get the first command. And this whole combined command, we can call it half square. because we have traversed two sides of a square. And this can be bound to the POV down button of the joystick. So this thing on the joystick is called POV, in case some of you don't know. And the downside of the POV is called POV down. So if everything goes well, by pushing the POV down button, we're supposed to see robot do half a square. Let's see. Robot is driving, robot is turning 90 degrees, then driving again, and turning 90 degrees again. So half a square works. So exercise 5 is, instead of making it half square when we press the POV down, can we make it a full square? I think I know what to do. So this is one side of the square. This is the second side of the square. All I have to do is I need to copy and paste the commands for the third side of the square and the fourth side of the square in here. And exactly. And connect them all together. So I can say and then at the end of this command, if you want to do a multi-line command, and then Daniel, can you show us how to test the robot with the POV down button? Which one is POV down?
This?
Mm-hmm. Why don't you press it? And the robot is doing a square dance. One side of the square, second side of the square, third side of the square, and the last fourth side of the square, and the last turn. Do you think it works?
Yeah.
Thank you.
I ain't afraid of no ghosts. If you see things,
Playing with the robot and playing. The robot doesn't have battery. And now we need to charge it again. So there is be more battery even. Thank you for watching our video.
And see you in the next one with a slightly bigger robot.